Cool. Hello, everybody. So welcome to MBL302, where we'll be talking about how Flipboard has scaled a mobile web app to 100 million clients and what we're going to do beyond that. So let's go ahead and get started. So I'm Joey-Parsons. I'm the head of operations at Flipboard. Previously, I was at Clout building out the big data infrastructure that powers the Clout score. I was at Sugar CRM, where I helped build out like our SaaS on-demand platform, and also at Rackspace in their very early days, back before the cloud when it was just managed hosting. So really excited here to talk to you about what we've got going on in terms of the cloud usage at Flipboard. So full disclosure, I've been at Flipboard for 2 months. I just joined pretty recently. Taking this speaking engagement was actually a lot of fun because it made me really have to go deep with everybody on the entire operations and engineer team and really kind of learn about everything that happened over the 3 years of history at Flipboard and why we are where we are today. So I'll be sharing a lot of the personal stories that I learned from them that really kind of shape what we've got going on. So how many Flipboard users do we have in the audience? Exciting. Very cool. So for those of you guys that don't know what Flipboard is, we are basically building the world's best personal magazine. We work on pretty much every device, whether it's a phone or tablet. We just recently migrated our magazines to the web. So the infrastructure for all of this has evolved greatly over time, as the operating systems for those devices have become more robust, and just the hardware behind them has allowed us to do a lot more on the device side. So we work with a variety of the top brands in the world. So not only do we ingest the content that they provide, but we also crawl the web and grab RSS feeds and different just content out there to help create an immersive, beautiful experience of content from around the web. We also take social signals from a lot of the top social networks out there and pull that information in and build recommendations for you so that you can have the best experience for you. So what do you end up with? You end up with a set of magazines that are tailored for specific subjects and categories that you can choose to create your own Flipboard. Earlier this year, we actually launched the ability to anybody to create their own magazines, right? Basically, you can flip content from within Flipboard into your own magazine, or with our bookmarklet, you can flip directly from any web page on the internet. And just earlier this week, we actually launched shopping. So you can actually flip content for sale into your own magazine to build kind of a shopping catalog, and you can actually integrate that within within a Flipboard magazine. We launched with Banana Republic, eBay, and Levi's just earlier this week, to accomplish that task. So there's a lot of infrastructure from the API that serves that content, the batch processing engine that we have that builds the recommendations, and then all the service and basically creates all the services that we've created. And it didn't happen overnight, and it wasn't easy. But we made a bet since day one on Amazon Web Services that they were going to be the partner that we needed to be able to scale our growth. And not only we don't just use EC2 or S3 and build all our service on top of that. We actually use a lot of the value add services that Amazon provides. So let's go ahead and get started. So the reason for this talk is to kind of talk about what makes mobile apps different than web apps, right? There's a lot of very kind of things that make sense, like Wi-Fi versus slow connectivity, right? We have users all over the globe, so having the kind of closest point of presence to them and to be able to serve the content quickly is incredibly important. And there's variances in bandwidth in all the global carriers. Every mobile device or tablet has a local cache, and you should use this aggressively to be able to control your behavior during latency. One of the things that we did early on at Flipboard is we architected our service so that we could experience 15 minutes of downtime on the server side and not have any bad user experience in the actual app. So we cache a lot of data so you can continue flipping and continue reading and continue looking at content even if our backend service is down. And that saved our ass quite a few times. So it was an architecture decision that we made early on that really helped us out there. So then, these are also, like I said earlier, these are incredibly fast devices. You can do a lot of computation on the actual device. So, what people might assume that with Flipboard, the entire layout is generated on the server side, and then we're basically just displaying that content on the local side. We actually, the computations around layout actually happen on the actual device, because every device is different. And we also do some interesting things with our ads, to where the ads aren't automatically injected from the server side. They're actually, on the device, and the logic for how they get injected within your Flip feed actually happens through there. So, one of the ways that we're going to kind of phrase this talk today is we're going to take you through, some very distinct stages of how Flipboard grew. The first stage I'm going to talk about is kind of like the prototype stage. This is where we went from 0 to 1 million users. This was the very early on days of Flipboard, when we just were on the iPad, right? And there's a cute little magazine about babies that that kind of demonstrate where we were at that point. So, in order to kind of get things out really quickly, we had a pretty simple stack. We had a very monolithic Rails application that handled basically everything, every single service request that came to the server side. It was completely in Rails. We used RDS, and we also used MongoDB, and we heavily cached things in Memcache. And at that point, we were just using EC2, S3, and RDS at that point. So, very limited use of Amazon, but we were actually, starting to kind of really build our tooling and understand how it could really help us. This was 3 years ago, so, there wasn't a lot of instrumentation that we could just grab and begin using. And also, we were launching a new company, right? We didn't have a lot of time to invest in a bunch of different services, and we just needed to get something out the door to see how people would use it. So the initial launch night, like I said before, we only launched on the iPad. We were one of the first kind of flagship applications on the iPad, and that initial launch night was actually pretty interesting. So, we submitted the app to the App Store, it got pre-approved, and everybody just sat around for that time. We were going to be like, okay, let's push the button, let's go, let's launch it right now. So we launched the app, and at that point, the only metrics that we had in the entire system were CloudWatch, right? So we're watching the CloudWatch metrics as things start happening. We see a few users roll in, it starts, tens of users start rolling in, and then hundreds of users start rolling in, and everybody's really excited. The company's really stoked. Everybody's cheering, drinking, having a good time, and suddenly all those CPU metrics on all those machines that we're looking at just start spiking, and everybody's like, crap, what do we do? So we immediately just start spinning up more Rails nodes, right? Let's get some more stuff out there. We need some more capacity to be able to handle the amount of traffic that we're getting, and it was a good thing, right? We wanted that amount of traffic, but we couldn't just handle it. And suddenly, as we're using our deploy tool to kind of get things out there, we run into the EC2 max limit that our account had been and this is the evening. This is 8 or 9 p.m. 3 years ago, Amazon support probably wasn't as robust as it is now. And like, crap, we simply cannot spin up some more instances. So we file a support ticket. We're waiting for things to get back to us. And at that exact same time, we're also ingesting content from Twitter and Facebook. Suddenly, they start rate limiting us, right? We simply can't, grab as much data as we need to be able to service our users. And it ended up being kind of a sticky situation, right? We planned kind of, what we could do in an event that, we got a lot of traffic, but we didn't think through some of the logistics around the partners that we're working with and the provider that we're working with that could have really helped that out. So we made a call that night to just basically say, okay, we've got to basically rate limit the amount of users that we're allowing on the service. So one of the other really good things that we did from day one is we built kind of a governor into the application, right? So we have a single service on the server side that basically says, continue to allow this app to work, or don't let it work. Don't allow new registration. So our head iOS engineer built something so that someone would come to the app, and even though we were fully launched, we wanted people to come in, we wanted them just to put their email address in, and we'd start slowly letting them in, come in first come, first serve by sending them an email and saying, go ahead and join the service. But if we hadn't done that, right, if we had just let it be as unable to spin up new nodes, we couldn't handle the service, we couldn't hit Facebook and Twitter, everybody would have had a really, really bad user experience from their first day with Flipboard. So, having that governor in there and building kind of your fail-safe so that, if the server side is down, it was really important for us, from night one. So So like I said, things that we should have done, we should have made sure that we could have provisioned the capacity that we needed to. It would have been a simple call to Amazon, a few days beforehand saying, we may need to launch 1,000 nodes, right? We may need to expand our capacity, pretty drastically. And, not thinking beforehand was a mistake on our part. And also making sure that, your external partners definitely understand the volumes that you'd be accessing them should your application actually take off like it should. So other challenges that we had is, like I said before, we had one big monolithic application, right? If one piece of that wasn't performing well, the entire system, suffered. So it's one of the things I'll talk to you about our next thing. And we had little to no insight into performance. Like I was saying, we were watching CPU graphs. It's not actually a good representation of what's happening on the end user side, right? We actually needed to be measuring latency, looking at the better results from like the ELB that we were using, and we were just beginning to build out our tooling for EC2. Even though we wanted to spin up 1,000 nodes, it wasn't as easy as it should have been. Even if Amazon had granted us immediately the ability to spin up 1,000 nodes, it would have been a chore on our side, and we still had a lot of manual processes at that point, and we had no centralized logging. We had no way to detect errors. We were just kind of, everybody flipping through the app, making sure it works, but not really understanding what was happening on the back end. So that was a pretty quick era in the Flipboard time, and we got to 1 million users pretty quickly. I mean, thankfully. And let's talk about the next kind of things that we did there. So at that point, nothing against Rails or Mongo or anything like that. We decided to kind of fully shift to Java. I think it was more kind of tailored to the staff that we had in place, and more kind of geared. A lot of us had a lot of experience with the JVM, and it was all about building towards what we knew could serve the capacity that we needed to. And also at that point, we added on CloudFront, right? Obviously, we have clients from all over the globe. Everybody had iPads from around the globe, and we needed to take advantage of all the different point of presences with CloudFront to be able to serve up a lot of the content that you get in Flipboard, right? So when you're flipping through Flipboard and you're seeing different pictures and stuff like that, a lot of that's coming from CloudFront. So architecture changes. Not only did we switch to mostly like JVM related services, we actually just broke everything up into microservices, right? This handles like URL shortening. This handles content processing. This actually services the API. And we were able to really kind of like really build out different scale profiles for each of those things. So instead of just spinning up 1,000 Rails nodes, we were able to kind of tailor the actual the machine type and the scale of it individually. Obviously, we moved all of our image content to CloudFront. And then we moved our primary data store to MySQL using Amazon's RDS. So, all of the information that we need to have, that we can't lose, that we can't regenerate simply by recrawling the web or sifting through the social signals, goes into RDS. This is like user account information, OAuth information. That's kind of like we simply cannot lose that information, and we're betting on RDS, and we still are for that information to persist. And we began really instrumenting. It's actually a wrong thing, but it was a complex system of Bash and local Ruby scripts to kind of build out all of our tooling around EC2. And then we started focusing on instrumentation, right? One of the challenges that we had early on is that we didn't have centralized logging. We started implementing syslog-ng, going to a central log host, building out metrics. I think this is when we began, initially using Graphite, and monitoring followed suit. So not just relying on CloudWatch monitors, but actually relying on a different system that can measure things at a different level. So one of the really interesting things that I actually found that was interesting when I first joined Flipboard is so instead of using at that point we weren't using Puppet, but instead of heavily investing in Puppet and using like Puppet TV or using Chef and all the information they get for their CMDB, the guys actually built out a full CMDB using SimpleDB. So just a very simple store that keeps all of the information about every host that we have within Amazon. So I'll take you through some of the fields. This was from like a test OpenTSDB implementation that I was doing when I first joined. So you have the host, and that's basically your instance ID in Amazon. The name of the host, the owner. This is really good for us internally. So if it's a production system, it's probably owned by ops, right? We do have some systems that are owned by engineers within production, but most of the production systems are owned by ops. But these can be owned by developers. That way we know like who owns the system and who's responsible for it. Should we have any problems? The service, right? We can easily take things, and we've instrumented a lot of the systems, all the microservices, to have a flag to either be in service or out of service. This automatically takes nodes out of monitoring, takes them out of HA proxy, and we build those services regularly to make sure that we're respecting that flag. The AMI, we want to be able to know the AMI that was initially used to spin this up, the type of actual instance that it is, the location, knowing exactly where it's at, and then we start getting into a little bit of the kind of like the Flipboard glue. So we built out kind of a role and a subclass mechanism. So you can have a particular type of machine or a particular type of service, and then we have different like subclasses within that service that do separate things. So it's kind of like our little hierarchy in terms of how we organize. And then we have groups. I'll get into why groups are important to us later, but we map groups to, we somewhat map groups to actual regions as well, but I'll get to that a little bit later. And then production, like pools, we have production pools, we have dev pools, we have staging pools, beta pools, and these kind of segregate different services so that we understand which environment that they're in and what they should talk to, and obviously like public and private IPs, right? So some of the interesting tooling that we've built around this is that we can all of our tools start with FL. That's one thing that I'll talk a little bit about. We name everything beginning with FL, and these are a little bit different. But basically, this is our Flipboard instance describe script. So you're passing it in the role flip, the pool production, group service, or group 0, the service that it's in, which is it's in service, and then the owner of ops. So basically, I want to see everything that has the role flip, that's in production, that's in group 0, that's in service, that's owned by my team. And basically, we get back this one node, and we get all the information about it right there. So it's a really kind of powerful thing that I'll show you a little bit of how this helps us out. But like I said before, it powers our monitoring, it powers HA proxy, it basically powers everything that we do on the operations side at Flipboard. So one of the things that happened, I guess it was about 2 years ago in November, like right around this time, we launched the iPhone. So the iPhone was a huge launch for us, right? We're going from just simply the iPad, not like the iPad tablet hasn't like proliferated around to everybody, but 2 years ago a lot of people were using iPhones, and it was something that we knew that we'd have to really kind of plan for and scale for. But we were also doing 2 other big things at that same time. We actually launched our feature Cover Stories, which is basically a feed of a magazine of all the other magazines and recommendations for you directly within Flipboard. So it was a big kind of new piece of logic that we had within the application. And we also launched HBase that night as well, which was powering the Cover Stories magazine. So it was a huge night, right? And we looked at everything that could have gone wrong with HBase, everything that could have gone wrong with Cover Stories, and really kind of made sure that this would be a successful launch. But as everybody knows here, things happen, right? There's something that you weren't thinking about, something that you didn't fully test, something probably will go wrong. And with us, the same kind of thing happened. It was, in the evening, everybody was really excited. We're going to the iPhone. Everybody's playing with it on their phone. We push the button, and it's out there. And suddenly, we just start seeing, all of our monitors start just blowing up. Metrics are, flying off the roof, and the story that everybody tells me is that, it was, 3 o'clock in the morning, we're noticing some significant issues in MySQL, right? Like RDS is just like backed up. We don't understand what's going on. We're looking at a bunch of different queries, and we just realized we can't handle the capacity, right? We're using just kind of a simple like master and read replica at that point. And the really cool thing about this is that the guys had to come up with a solution, so they built sharding in just a few hours. And building sharding is a chore in itself, but building like a sharding system and not having to worry too much about MySQL configuration and getting things right there and leveraging what we could with RDS was really important for us to be able to push through that evening. The crazy thing, though, is that sharding didn't actually even matter. We actually had just one bad query that our CTO at the time noticed, and he's like, oh, I fixed the query, and then the performance went great again. So, but the good story is that with RDS, we were actually able to build out a sharding mechanism that we still use today that came about in a very kind of like scary way, but we were able to get through it and come up with a very cool solution that we could scale with through time. So let's talk about scaling fast from 10 million to 100 million users. One of the reasons that we actually grew so quickly is because we launched on Android. Unfortunately, I don't have a really good story about Android because that one actually kind of went very, very smoothly. So we learned over time, and we got better with what we were doing, and we're a few million away from being able to claim that 100 million user mark right now, which is a pretty exciting time at Flipboard. So, but as you can see, our stack has drastically changed at this point, and it's kind of cut off on the side. But pretty much a lot of JVM-based stack. We're running Hadoop, we're running Elasticsearch, we're running HBase. We do Redis for a little bit of Redis. We started integrating Puppet. We realized that a lot of the things that we were kind of hacking together not only were somewhat problematic, but at the same time, new people coming in, it was really hard to kind of get up to speed and try to figure out how to take things to the next level. We use Logstash to basically look at our HA proxy logs, look at and turn those into metrics. We also use it for counting out errors, shipping that information to Elasticsearch so we can search through it. And then we also brought in Storm, Kafka, and Kibana as the Elasticsearch viewer. So in terms of architecture changes, we focus pretty heavily on instrumentation. So like I was saying before, looking at CPU graphs isn't exactly like the best thing in the world, right? You want to understand how all of your services are fitting together. The one really cool thing is that we pretty much use HA proxy between every single tier of our service. So every single web service that we provide, whether it's external or internally to ourselves, is going through HA proxy. HA proxy has really, really good logs to where you can see the time that it took for an action to complete. You can see the amount of retries that it took, and that information works really well, flowing into Logstash and actually turning into metrics. And we actually also have direct-to-graphite writers from almost every single application in our system. So, we're looking at, how long did it take for an HBase put against a particular cluster take, right? And those are important kind of things when you're actually looking at, how your service is scaling and how it's performing. We started building out our pipeline of batch processing using Hadoop. So a lot of the recommendations and different things that we're powering out there are all using Hadoop. We started building out our pipeline of real-time processing using Storm, and Kafka is kind of the delivering system into Storm. But a lot of things like our usage metrics that come from our users and just general things that we need in a more real-time sense are flowing through Storm. And then we also had a keen focus on using appropriately sized EC2 instances. I can't even tell you how important this is. When you're growing really quickly and you have to scale out to kind of to service your users, you're just throwing hardware at it, right? You're like, I need another 1,000 nodes to be able to handle this burst that we're going to have this next day, right? But you really kind of need to take a step back and say, am I using the appropriately sized instance to kind of get the best bang for my buck and the best performance for my buck for what we're doing? So, one of the funny things, and it kind of ties into ties into Puppet, is that a lot of our HA proxy instances we were actually running M1 larges on. And the reason why we were running M1 larges is because Puppet's got a thick client, right? It can when it runs regularly, it can have a significant impact. And we were actually seeing on all of our HA proxy nodes every 30 minutes a brief little spike that was actually having an end user impact, because that brief little spike was slowing down the systems that basically talk everything internally and everything externally. So actually fixing that up and moving all of those to actually like M1 mediums and M1 smalls was actually a really good cost-saving thing, and really kind of helped us out to understand how we scale it. And we do that for periodically through every single one of our services. We look at it. We look at the new instance types that Amazon's released and make sure that we're actually utilizing to the best of our abilities at a certain performance, at a certain kind of usage scale, that we're using the right things. And then obviously moving off bash scripts and our Ruby scripts and getting towards Puppet. So one of the really cool things that we do is we do a lot of instrumentation from our actual mobile apps. So we have a single endpoint that basically takes in these metrics that the mobile apps actually create and pipes them into Graphite. So here you can see this is the iPhone 5 launch time. So this is the amount of time that it actually takes for the mobile app to open up on an iPhone. So it's a really good thing for us to look at, because if that first experience of someone clicking on the Flipboard icon from their Flipboard icon and suddenly it takes like 30 seconds to load after we've done our new release, either on the back end or on the actual client, we actually know there's a problem. And we instrument a ton of different things throughout the actual app, like how long it takes for like an actual flip to happen, how long it takes to pull up content, how long it takes for to get things back down from the CDN. So it's actually a really good metric, and you can actually see, we had a bit of an incident where things for just a short period of time there were jumping to 8 seconds, and that actually has a substantial end user effect. And just that few seconds, if that's the first time the users use your app and they're not fully engaged and they don't fully love Flipboard, that could be a lost user right there. And that could be, at our scale, that could be a significant amount of, new users that are just kind of going away. So it's really important not only to instrument what you have on the server side, but actually to really instrument what you can do on the client side within the operating system that you're working with. So let's talk a little bit about one of the reasons that's important and why I wanted to show that previous slide is what we do in terms of our deploys. So one thing you can do is you can always deploy everything at once, right? You could basically just push your code out there, hope for the best, not understand what could go wrong, and kind of shoot from the hip, which is something people do. But we made a conscious decision early on that anytime we deploy on the server side, we're going to deploy in groups, right? So our even-numbered groups are actually in US East 1A. Our odd-numbered groups are in US East 1D, where we're currently in a couple of availability zones. So what we do is that we will actually deploy to group 0 first, right? We want to see how the application performs with a certain subset of our users hitting it to ensure that it's actually going well, right? And we can actually correlate that to like the metrics that we get from both the client and the server side. So I'll show you how we do it from the server side. Using CloudWatch metrics is really good. So what I failed to mention early on is that everything pretty much sits behind an ELB, right? It's used for SSL termination. It's basically what proxies down to all the HA proxies that proxy down to all of the other services. So you can actually get some really great information out of CloudWatch metrics, right? One of my favorite ones is counting the rate of 500 errors, or 5xx errors as they call it. And there's also great latency graphs in there. So this is actually a deploy that we did to group 0. And you can see kind of the rate of 500s coming across here. And it's pretty even, pretty stagnant. Nothing crazy is too going on. But suddenly we did this deploy, and that's the vertical black line that you see there, and our 500 just jumped, right? If we deployed to every single service or across all the groups at that point, we would have had a down service, right? There would have been a lot of bad experiences on the phone side. So it's really important to be able to, on your infrastructure side, be able to deploy in groups so that you can understand like the ramifications of what you're doing. So this is the next slide on here. This is basically deploying to the next logical group, group 1. And you can see that, after we noticed after we noticed that blip, we went back and made sure and fixed the issue, and then continued on with our push. So what we do is, we'll deploy zeros, we'll deploy ones, and then, after that, after we feel things are pretty good, we'll batch deploy through the rest of them just to ensure that, we get the release out there quickly. One tool that we use pretty heavily here is Graphite. Are a lot of you guys Graphite users? Yeah? Yeah, so Graphite's a really good tool because you have a bunch of different, there's a bunch of different producers for Graphite, right? We've written some of our own. We do a lot of stuff coming through Storm. We do a lot of stuff coming from Logstash directly into StatsD that pipes into Graphite. And this is just kind of like our very simple Graphite setup that we have at Flipboard. And basically, one of the key things to scaling it in AWS is that you've got to use multiple nodes, and the more disks you can put behind it, the better, right? Graphite's a very disk-intensive application, and be able to access your metrics and write a lot of metrics is pretty important to be able to actually understand and quantify what's going on in terms of your infrastructure. So if anybody wants to talk to me about this afterwards, feel free. But we use pretty much stock Graphite, and it's done really well for us. So we actually consume millions of metrics on a per 15-second basis in Graphite. So these are metrics coming from our servers. These are metrics being fed into Graphite from CloudWatch. There's actually a really great open source project out there called AWS or CloudWatch to Graphite that'll basically go to, you put in your API secret keys, and it'll go out to CloudWatch, pull down all your metrics, and then pipe them directly into Graphite. So we love CloudWatch, but being able to correlate it with all of the other metrics that we have in our system is pretty important for us to be able to do causation correlation between what's happening on our stack. So we pull in millions of metrics, and this is kind of the thing that I wanted to talk about in terms of correlating things. So this is D3.js using Cubism, and it's basically each one of these horizontal lines is a horizon graph within D3. And basically, it measures the amount of latency between different tiers in our stack and displays them as a horizon graph. So there's a really cool JavaScript plugin called Cubism that can take a bunch of these horizon graphs and stack them up against time so that you can see across your stack, what's exactly performing poorly. So, that top line there is our actual external ELB latency, right? So this is the end user effect of everything this is the end effect of everything that's happening within our system and how long those requests are taking when an end user requests them from their actual device. And each one of those other pieces are different web services that we have, and then the darker colors are our data stores. So you can see that as with horizon graphs, the darker the line gets, the worse the service is. So you can see the vertical line on the right there at the top. It says 12:33 p.m. So at 12:33 p.m., this was the millisecond latency across all of those pieces. So one of the most important things for us, when you get paged in the middle of the night and you're like, shit, what piece of my environment is actually doing poorly. And you can actually correlate different events, or you can correlate across your entire stack, what's actually happening. So, if that top line had simply gone red, and I noticed that it correlated to an event that happened near the bottom there, I would know to look at that data store and say that's the place I need to look in order to affect up the chain of what's exactly happening. So, we try to organize this in terms of the stack to understand, what exactly is happening at the top and how that correlates to all the events that are happening on the bottom. And we actually do a lot of monitoring via CloudWatch right now, and we directly send those things into PagerDuty. So not only do we monitor everything through our own monitoring system and then have some metrics off Graphite, but we actually take advantage of some of the things that we can do with CloudWatch, especially with RDS. So one of the best place obviously to get metrics about what's going on with an RDS is directly from Graphite. So this is something directly from CloudWatch. So this is one of our database replicas having like high replication lag. So that means that we're probably very much oversubscribed on the masterpiece in terms of writes because the replica can't keep up. So this is a signal to us, maybe we need some more POPs or move this to more of a scaled out approach. So, but yeah, it's pretty cool because you can integrate directly into PagerDuty, just stick an email address in there, and it'll send an alert, and it'll send the clears and clear things out properly. So, some of the kind of grand lessons that we've learned to kind of this point. So, on the operations side, in my opinion, you never want to do you never want to kind of build everything that you possibly can. Like when you're making a bet on Amazon, it makes things simpler to actually use their services. So, using RDS, using Redshift, using Route 53 for DNS, it's actually saved us a lot of time and a lot of heartache, and we can actually focus on building a great application and building something that scales. Using SSDs where applicable. Most of our H-based clusters are using SSDs. Most of our Elasticsearch clusters are using SSDs. Our Graphite hosts are using SSDs. Anything that's like significantly heavy on the disk I/O side, you've got to use SSDs because it'll make such a significant difference in terms of your scale. I know that they may cost a bit more, but it really does make a huge difference in terms of like the end user experience. And then understanding your scale and your needs going forward and investing in reserved instances. So pretty much, the majority of our environment had been on-demand instances, and we were paying a significant amount of money to Amazon every month without really kind of trying to figure out how we could save a bit of money and make better uses of our resources. So we've heavily invested in reserved instances to keep our costs lower. And we've actually really invested in 3 years. So what we've seen is that if you invest in the kind of like the 3-year time cycle, the payback's actually 9 months, right? So you're not going to the instances that we buy over a 3-year cycle for the most part are the payback's actually 9 months, and it's drastically reduced our service costs. But you also kind of need to allow for flexibility, and because your needs are going to change, right? The types of instances that you're going to buy and the types of usage that you're going to have could kind of drastically change over time. So we keep a significant amount of on-demand instances out there so that we can really kind of play with things as we need to. So here's kind of like a laundry list of all the Amazon technologies that we use. Obviously CloudFront, Route 53, EC2, S3, Redshift. We do a lot of our BI and analytics through Redshift, and it's actually, going out and building out your whole kind of BI infrastructure is a really difficult thing, and our data engineers really love Redshift, and it's made things really simple on them. RDS is our primary data store. We use SimpleDB for, like the configuration management database that I was showing earlier. We heavily use SQS. I think, we're in the hundreds of billions of messages that we push through there on a monthly basis. It basically handles kind of like how we crawl, right? Like as we crawl, our crawlers are picking up messages off of SQS and figuring out what to do next. We've started using Elasticache a little bit for Redis, and we like where that's going. We run a lot of Memcache on our own, but we're really liking what's happening with the Elasticache service. And then CloudWatch, right? This is probably one of the most important things in terms of monitoring and kind of understanding where your needs are. So where do we go from here? What happens when we hit 100 million users? Like what's beyond that? A few of the things that we actually really need to do is better use auto-scale groups. We provision things as we need them. We provision things when we know that we're going to need them. We're very cyclical with people using Flipboard. A lot of things happen after people get off work. At the end of the day, before they go to bed, when they wake up, those are like our highest usage times. So we understand that we need to be over-provisioned at those points. But we don't do it automatically, right? We actually need to really invest in auto-scale groups and blend in some spot instances in there as well, so that we can better kind of like, from kind of a cost perspective, understand and better utilize our resources. Predictive analytics. We get a lot of signals, right? We get a lot of signals from both our users and our metric system in terms of like how our servers are performing. I really like a lot of the things that like Grok's doing in terms of building out like predictive platforms to understand problems before they actually happen, right? Like as you start seeing things go a little bit wrong, or using like Holt-Winters algorithms against graphite is something that we're going to heavily invest in. Automated remediation, right? As you know that things are about to go down or is going to have problems, if you have a certain runbook that you execute every time, why would you have a human run it, right? You should invest in actually remediating those things automatically, and then always, a heavy focus on making sure we're using the right instance types. We had the privilege of playing with some of the C3 instances before they came out, and we're actually really excited about the workload that those things can use to be able to help us out in the future. A lot of our recommendations, a lot of our things where we have short amount of like transient information that's there for just a little bit, that would really be benefited from using the SSDs and the higher computations is going to be really important to us. And then taking advantage of new AWS products, right? They're constantly coming out with new things that are really beneficial, and we made some choices really early on to build some of our own infrastructure, and it would have helped us a little bit to have those things earlier, but going back and reinvestigating across the entire stack what we can use better. And take that load off of our operations team so that we can focus on continuing to build things out. So the unknown's exciting. It's a magazine into the wild, but we're really excited about what we can do to make the end user experience constantly better. How we can lower that launch time that it takes. How we can lower every single action that happens with the application. And it all comes down to really building out metrics and really building out an infrastructure that you can grow with. So. That's it for now. Questions?